First of all, I would like to tell you that computers and computer informational system is creation that use electricity, electrical static field, dynamic field, motorized field, magnetic fields, magnetism, and it used conductors, semiconductors, it used liquid crystals and transistors, microchips, and so on. So this is really complicated electromechanical and electrochemical device. To understand principle of computers, we need first to imagine what is matter we use every day made from. But to speak about it, I would like to tell you that the matter that we use, like wood, metal, water, um, could have three aggregate states like liquid, gas, or hard body. And these three states belong to matter. So liquid is contain matter, gas contain matter, and hard body. So what is inside of this matter? What the smallest element? For the smallest element is particle. But particles, they aggregate in, let's say, the kernel of atom, the kernel, so of atom. You can see this little circle. This kernel could have the positively charged fractions, particles, named proton. Proton actually positively charged. But atom is electrically neutral. So to be electrically neutral, the atom supposed to have something negatively charged around, and this is electronic cloud. Electronic cloud, folks. Electron is negatively charged particle which actually charge equal to proton. So proton and electrons, that is indispensable part of atoms, but they also contain so-called quarks and also contain hyperstring. But this is very difficult and complicated physics and mathematics, so we will not review this. You probably will need to take physics class. So this very simple atom could contain the neutral piece of energy named neutron. Neutron is a heavy particle, but it doesn't have any charge. So the atom that I actually draw is atom of hydrogen. Hydrogen. Atom could have more protons and more neutrons, so they're supposed to have more electrons. So that we can figure out 8 protons, sum of neutrons, and electronic clouds of 8 electrons, and that is oxygen, the oxygen. So this is atom, folks. In the gas, if you take the uh, volume of the gas, let's say you'll have a can like this and put the gas inside, the atoms will be chaotically placed and they are in permanent motion. In permanent motion. If you compress the gas, the distance between atoms will be smaller and the density of the gas will be higher. If you compress and compress and compress, in a certain moment, atoms will be much closer to each other, and then will create the hard body. What is the difference between hard body and gas? The difference is the hard body could have so-called crystal crystal lattice or crystal grill. When atoms are located in certain volume from the fixed distance from itself, and atom kernel also connected to each other. Look at this. This cube is a crystal. So I will continue drawing. So this little crystal could be continued with more atoms, like this. More atoms, and more atoms, and more and more and more, folks. So until the material is finished. So I will go this way, and you will see that end and this end. So that is crystal lattice of any hard materials. Let's say diamond, glass, iron, copper, uh, silver, gold, and every metal. By the way, folks, we can say some materials are conductors and some is insulators. What is the difference between them? Usually metal is conductor. Why so? Because the grill or crystal lattice is so um, is so powerful connection between the kernels of the atoms. So electrons feel themselves free and they are exactly inside of this volume. And they can fly inside of this volume in the middle of the crystal, like I draw it here. If you open topic about matter, you will find animation picture about this. You probably already seen it. Okay, so that is metal. Folks, dielectrical insulators. Let me put here dielectric. Dielectric is rubber, dielectric is glass, dielectric is wood. So in the wood, electrons is positively connected to the crystal lattice and cannot move. They chemically connected to this lattice. And they cannot fly inside of the crystal lattice. Now, when we speak about electrons, electrons, by the way, can feel electrical field. So you know the different, um, differently charged particles could be attracted to each other. So if I take positive charge and connect to this end of the lattice and will take negative charge and connect to other end of the lattice. So electrons will start moving and the concentrated of electrons concentration will be on the positive. I'll put minus, 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 minus here because what minus is. Minus meaning negatively charged particles. They will be concentrated in this end. But if we concentrate negatively charged electrons on one end, other end must be charged positively. So positive charge will be on other end. And number of charges will be equal because that material is electrically neutral. But how can we create this charge, folks? How can we put plus positive charge on one end and negative charge on other end of the conductive material? We will take the same piece of metal here and I will connect it to the chemical source of electricity. So that will be, let's say, double A battery. And that is minus, that is plus. This is double A. The chemical process inside of this battery actually creates electrical field and the field is concentrated on the small electrode here. This is positive electrode and it attracts electrons and negative electrode attract the positively charged particles. But folks, if we create this kind of counter and we call it electrical circuit, then electrons, when they counter is closed, the loop is closed, the electrons will start their motion through the battery, because battery actually conductor, and they will move through the contour, and this motion will be active until the battery juice is active. You know, when the battery is weak, the electrical motion of the electrons will be not in motion anymore. So folks, this process, when the motion of electrical particles actually is feelable and manifests itself in the conductor, we call it electric current. Electric current. This electric current, folks, can manifest itself, and you know the electrical devices such as vacuum cleaner, electrical stove, and ovens, lamps, can manifest itself with the physical events. For example, in the lamp, when we have a little lamp, I will draw the lamp like this. You can see it. The lamp has a little filament that actually connected to the base. And when you connect this base to the battery, I'll put battery here, double A, and another piece we will connect through the switch. Switch looks like this, right? That could be button on the flashlight or the wall switch for the any electrical lamp. So when you close the switch, the lamp will shine. So the manifestation of electrical current here is the light. But if you have electric motor on the fan, and I'll put it there, this is propeller of the fan, and fan could be connected to the battery, AA battery. So when you close the contour, the propeller will start rotating, and this rotation will move the air, so you will have fan or vacuum cleaner. So folks, electrical current can also raise the temperature. So that will be electric kettle or electric stove, and we can see even much more powerful electricity. That could be the electric bolt, electric discharge in the in the storm, right? Thunder will create electrical discharge, very powerful discharge. So again, you need to remember that electricity could be created by a chemical source of electricity, and it could run through the conductor. Folks, let me tell you a couple of things about liquid. When you have a liquid, by the way, using, this is our liquid in a glass. This is liquid in a glass. So liquid contain, let's say, the water. It's H2O, two atoms of hydrogen and one atom of oxygen. When they connected, they look like this. This is small atom of hydrogen, that is oxygen, and another hydrogen. So the geometry is like this. It's 120 degrees. So if you put here two electrodes inside of the water and connect these electrodes to the battery, the electrical current will go through the water. Electrical current will go through the water. Liquid conductors, named electrolytes. By the way, human body contain a lot of electrolytes, folks, and the electrolyte, when you dissolve um, sodium chloride in the water and drink it, that is mostly the solution that you have inside of your blood. And you also have potassium chloride and calcium chloride, and that is um, sodiums that you have inside of the human organism, because 80% of the human organism actually contain water. Folks, I will not open the secret if I tell you that if this is a human hand, okay, and this is muscle of this hand, you can connect it to electrical source like this, to electrical source, to the battery, but you need a little bit more powerful battery. So if you connect it to electrical source, muscle will start working. It will go in motion. So in this case, folks, physiologists, they made discovery that human organism is under control of the electricity. But what is the source of electricity that control muscles in human organism? That is nerves. Nerve, folks, is biological conductor that provide manifestation of the electricity in human organism. Okay, so that all about electricity. But folks, people all the time, the people live, they would like to send long term messages, meaning from me to you, you in Brooklyn, I'm in Bronx, or maybe I'm in Chicago and you in Moscow, Idaho. So how to send messages to each other? And that is another matter, that matter named information. Information. The very primitive information matter is just answer to the question, yes and no. Yes and no. This is elementary messages that have only two options, yes and no. But look at this picture with a lamp, with a lamp, and it has relationship to yes and no. What kind of relationship? The lamp could be in a state, lamp is turned on and the lamp is turned off. Can we associate yes as on and no as off? Definitely we can. Definitely. So, can I transmit my answer to somebody with my pencil? Look at this. Pencil with graphite up, the stylus up, is yes. Pencil with the stylus down is no. So, folks, logical matter, meaning the answers yes and no, could be transmitted from one individual to another with some kind of material signal. And any materials could be transmitters. Let's say I sent you the piece of paper which is white, and you can say white is no. When I send you black piece, that will be yes. And so on. You can design the transmission idea yourself. But let me tell you a couple of words about what people actually designed. I need to take another piece of paper. Okay, what people designed. So, before I tell you that, I would like to speak about magnetic field. You know that magnet could be snapped on the refrigerator because refrigerator has a steel surface. Steel surface and magnetic element could attract to each other. But folks, magnetic field also could be generated when the electron is in motion. When electron is in motion, that around its trajectory will be magnetic powerful lines like this. And this is vector. vectors, so they are directed. The same thing happened when you use connector. Connector from plus to minus will provide the motion of electrical current, and this connector will create magnetic field around it. So I will put this rings because magnetic field actually goes as rings. How can we amplify the magnetic field? Because sometimes we need to amplify magnetic field to make it attract something heavy. And then people design magnetic coil made with conductor, but they have many loops. And what else they put? They put to amplify the field, they put iron kernel inside like this, and the iron goes this way, and the coil is around this iron. So plus minus. So it works this way. When you connect the battery to this device and the current is on, anything that near this magnetic device named solenoid, anything like a key, right? Let me draw the key. Key is like this, small key. This is a key. It will be snapped to the solenoid kern, and we can see it. When the device is off, the key will unsnap and fall down, let's say, on a table. Can I say, so when this device is active and the ferric, meaning iron key, is snapping to it, can I say this is yes? Definitely I can. Then, when it fell down from the device, when the device is inactive, solenoid is inactive, can I say this is no? Yes, definitely I can. So this is already informational device. Informational because it brings the answer to the question. Next big idea is like this. Can I install the battery, let's say powerful battery, in Bronx where I am now, and I will put wires, two long wires, but this in Bronx I will put key, meaning not a key but switch. And then in Brooklyn I will make coil with a kernel inside and put, let's say, any iron device, any iron, let's say key. Now take a look. That is your eye that looking at the device. This is my finger that turn this switch on and off. So when in my end, and this is Bronx, let's say, I will push down this switch, then you will see the key snapped to solenoid. When I release this, then you will see the key unsnap. Folks, one of the genius of this earth, his name was Samuel Morse. In 1830s, he considered that we can transmit information through this device. And he said these wires could be on a poles like this, so we can make a pole, make a T on this pole, and another pole, and another pole, and another pole, and we can put these wires. This is one wire and another wire. Then you can put this wire and another wire. You probably have seen it on the poles because this thing is still working, still active. So this Samuel Morse said, when I push long time, so the switch will be long time, this snap will be long time, and that will be like long time pulse like this of electricity. And he said, let's say I will name it dash. When you put this short time, the pulse will be very short. And he said that will be dot. Wow. So when you hear snipping and unsnipping of the key, you will see something like this. So what is this? This Samuel Morse telegraph. Telegraph. Telegraph can transmit information by using dashes and dots. Dashes and dots. And this is a lot of letters that can be substituted by dashes and dots. Take a look. Letter A, dot and dash. Letter B, two dots and one dash. So letter A like this. Letter B like this. And the entire alphabet could be substituted with the notes, with the dots and dashes. So they name it Morse code. Folks, what is code? Code is the table that setting up the corresponding between real letters A, B, C, D, and its representation with how they represent with different material elements. So we said dots and dash, this is electrical pulses that attract or disattract this anchor, the key. So material looks like will be like this, dot and dash, two dots and one dash. By the way, S will be three dots, O will be three dashes. That's what I remember. I used to remember this entire table, but now I don't because I just forgot it. But you can find Morse code table in the Google if you find it, if you would like to. So folks, this is unidirectional. Unidirectional. So transmitter is in Bronx and reception station is in Brooklyn. Can we make the second one? And that will be another two wires. I will put them through all of these things what I did, and here I put the battery plus minus, the switch, and here I put the solenoid with a key. The direction of information will be this way. I'm sorry, I need to disconnect it. Call from Rises Jerry. Call from Rises Jerry. Give me a second, I will disconnect my phone. Thank you. Okay, so you see when you connect only in one direction, that named simplex. When you have dual connection, dual direction, they call it duplex. So duplex can transmit and receive information. But folks, we need to have somebody like a man who remember all of this code table from Morse code. What is advantage of this? It's cheap and it's very primitive. It's very simple. So you can just put two long wires on a poles and put the coil on one end and battery with switch another end. But folks, disadvantage of this is the following. You have three code elements. Three. What is three elements? The dot, the dash, and the space. Without space, you cannot recognize dots and dashes. But naturally, the answer of human question is yes and no. So this code has only two elements, yes and no. Can I say yes is 1 and no is 0, just to connect it to mathematics a little bit. You can ask me why yes is 1 and one no is 0. If I have $5 and I gave it to you, you will have $5 if yes. But if no, that will be multiplied by 0. And if I said I gave you $5 multiplied by 0,
Excuse me, sorry,
that will
Professor.
be no. Yes.
I have an English class at 6 o'clock. Can I leave at 6, please?
Yes, you can leave anytime, folks. Don't interrupt me because the class is in recording states and will be recorded. And you can listen it when it will be placed uh, in the Blackboard.
Okay, no
Please
problem.
mute your microphone. All right, so you can see this. Yes is 1, no is 0. In addition to this, I will say left is 0 and right is 1. I can say more. I can say open is 1 and close is 0. And so on and so on and so on. The most important is true and false. True is 1, false is 0. I need to change my piece of paper. Alright, folks. So when we set up this, like current is on will be 1 and current is off will be 0, without any dashes and dots, we can think how to make these ones and zeros to send and receive information. But what is information? Information is what we speak. When I speak and you listen, then you already use code table. You cannot believe me, but it's true. What is this code table? This is code table that actually convert my sound of my articulation with words and letters that is reflecting in your brain. So when I use a different language, that code table will be different. So my transmission code table will be different than your reception code table. I can switch it to Russian language, and then you will not understand a clue. Let me do this. Привет, ребята! Как вам нравится моя лекция? Вы довольны ей? So I choose different code table on transmission, but you cannot switch your reception code table. Your code table is still English. So to make you understand this, I need to switch my transmission code table to you so you will understand. So folks, first rule to understand information, the code table for transmission, the same code table for reception. So device that work with a code table on transmission end must be the same and use the same code that on reception end. Then let's try to imagine this device. If I have this information 1 or 0, this information, folks, could be named. People who use this information, they gave this name. So a little dot like this that can be black and white, or the current can be on and off, or the light that could be on and off, and so on, yes and no, bring the information that is equal 1 bit. What is bit? Why they call it bit? Because this is binary digit. Binary digit. This is abbreviation. BIT, binary digit. 1 bit. So 1 bit could be either 0 or 1. So 1 bit actually can transmit two variations. Two variations. One for 0, one for 1. Using 1 bit, I can encode two letters, one for 0 and one for 1. So that will be letter A, that will be letter B. Nothing more, only two letters. But this is two wires. I mean, this is one wire that could be active or passive. One wire. But what's happened if I use two wires? Two wires or two bits? Two bits. I'll put this as 1, this is 2. How many variations I have here? Let's see. 0, 0, both inactive. 0, 1, 1, 0, and finally 1, 1. How many variations here is 4? So for 2-bit, I have 4 variations. Can I use it for letters, to encode our letters? Definitely, but I can encode only 4 letters, A, B, C, and D. How many letters I have in my alphabet, in English alphabet? You can say 26, but you forgot that to say Mr. President, I need to use capital letters. So 26 small letters, 26 capital letters, but also punctuation, like colon, semicolon, comma, dot, dash, big dash, underscore. What about mathematical symbols, like a root, like um, x square? What about index, like OH2O? So totally, folks, I need to have 256. When people calculated how many symbols I need to have in encoding process. Then the question is, how many bits I need to use to encode totally all letters and all symbols, punctuations, and whatever that I use in my alphabet. Let's try 3. For 3-bit, I will have, I believe, 8. Let's see. 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, and 1, 1, 1. How many letters I can encode with this? 8. But it's not enough. That will be A, B, C, D, E, F, G, H. What about 4-bit? 4-bit 16. It started with 0, 0, 0, 0, 0, 0, 0, 1, 0, 0, 1, 0, and so on and so on, and finished with 1, 1, 1, 1. The same as here. 16 positions in this code, 16 variations will give me opportunity to encode 16 letters. I will not list them here, you understood. Let's go further. I would like to take 5-bit. Definitely, every time I add 1 bit, the number of variations doubled. For 5-bit, that will be 32 letters, or 32 variations. For 6-bit, that will be 64 variations, or 64 letters. For 7-bit, that will be 128 variations. That is already a lot, so I can encode 128 alphabetical symbols. Oh, by the way, I forgot numbers here. Numbers that will be 0 to 9. Okay? 7-bit, 8-bit, 8-bit, double 128, that will be 256. 256 variations in this code, 8-bit. How 8-bit looks like? 8-bit getting together. So that will be a chunk of information which has 8 placeholders. 8 placeholders. Each placeholder contains 1 bit. But altogether, by the way, folks, altogether, they call it 1 byte. And 1 byte is the informational unit. we measure information with this unit. How 1 byte looks like? Let me put 1 byte how it can be. 10010001. That is 1 byte. But what about this one? 11001100. Is that byte? Yes. What about this one? 111000000. And this is one too. Folks, the byte is chunk of information that contain 8 binary digits. Could you tell me 3 is binary or not? No. Binary is only can be yes or no. So it's only 0 and 1. There is no other binary digits. So you cannot put 3, 2, 5, 7 in the placeholder for byte. It is only binary code. Only binary code. So folks, when America discovered that 8-bit could be the informational chunk that could be transmitted using 8 wires and make these wires sorry, active and inactive, we can transmit different letters. Say this is 10010001, and this combination will be letter A. So what American engineers consider? They said we need to have transmission code table and reception code table the same. How to do this? They made American standard. They call it ASCII. It read as ASCII. ASCII. ASCII is a code table that made American Standard Code for Informational Interchange. American Standard Code for Informational Interchange. I recommend you to Google this code and print it for yourself. So American Standard Code contain 256 code lines from 00000000 and up to 11111111. So folks, the last thing for today's session, I would like to tell you that a formula that allows you to calculate how many variations we will have if we have a certain number of bits in the code looks like this. Q, quantity of combinations, is 2 in the power of n, where n is equal number of bit. Definitely 2. 2 because we have only 2 digits, 0 and 1. And because we can have unlimited number of bits. So if you have, let's say, 5-bit, you need to calculate how many chunk of information you can associate with this. You need to calculate 2 in the power of 5, and that will be 32. All right, folks, that's what I would like to tell you today. I think this is enough. Usually I spend 2 sessions to bring people this kind of informational piece, but you have it in one piece of information. Let me stop the recording.